All right, welcome everyone to this very special workshop. Today we are doing an intro to GIS with QGIS. So this workshop is a collision of three different really cool things out in the world of GIS. The first one is this is a workshop with Maptime Davis, which is sponsored and supported by UC Davis Data Lab. So we've cross-listed this workshop with their workshop series. This is also being a part of the UC GIS Week conference as well. So we've got three, like I said, really cool things coming together today. And so we've got a really big list of participants. I am really glad you are all here because this is one of my favorite things to talk about. It apparently is not PowerPoint's favorite thing to do because it's not advancing my slides. All right, would not be a Zoom presentation with PowerPoint if something didn't go wrong right away. So today's teaching team, welcome everyone. My name is Michele Tobias. I am the GIS data specialist at UC Davis Data Lab. We have helpers today. We've got Alex Mandel from Development Seed and Naomi Kalman is also here. Both of them are UC Davis alumni and have worked on campus as well. So I'm glad they are here. We also have some folks helping behind the scenes from our Maptime Davis Council as well. That's the body that makes this happen. So you might be wondering, now that you're here, you might be here for various reasons. What the heck is Maptime Davis? I thought I was here for something else. So Maptime Davis is literally time for making maps. We have a workshop series that we do pretty much weekly during the quarter at UC Davis. The whole effort is coordinated by UC Davis Data Lab's Spatial Sciences Research and Learning Cluster, which is a part of UC Davis Data Lab. And like I mentioned before, it's coordinated by our Maptime Davis Council, which is a group of folks who make this happen this quarter. We're trying a new kind of board of directors, and I think it's working out really well. So if you want to get more involved, you can join us maybe at some point and join the council. You also might be here because you heard this is a data lab workshop. So what is data lab? So what we do at data lab.
Duration.
All right, can you guys turn off? Go ahead and make sure your mics are turned off so that we can limit the background noise. And I'll ask my helpers to take a look and the participants listen, just make sure everyone's muted for now. Thanks. So Data Lab is an entity on campus. We are housed within, both physically and metaphorically, within the library system on campus. We are actually in Shields Library on the 3rd floor. And our goal is to help researchers with data-related things. So we work with research training and community. We can help researchers with various data things. You can read the slide. We also do training such as these workshops, both through Data Lab and through our research and learning clusters and our communities. So we foster a number of communities, including Maptime Davis / the Spatial Sciences Research and Learning Cluster, as well as things like the Davis R users group. And we have a new Python users group and those kinds of learning environments. So that's Data Lab. You also might be here for UC GIS Week, which this is our 2nd year putting on this event. The pandemic facilitated the folks from all over the UC who do GIS to get together and say, hey, let's do a big GIS Week event. So this is our 2nd one that we're doing. And so far, we're really excited. We have almost 800 people registered as of this morning. So hopefully we don't have room for 800 here, but hopefully everyone that wants to be here is. And our goal is really to help facilitate work in the geospatial realm across the UC campuses and also with people outside the UC too. So you can join any of our presentations that are going on for the next 3 days. We also have Slack workspace, and I will paste the link for all of that information in the chat once I get through with PowerPoint and I can see my desktop. So how can you get involved if this Maptime Davis thing looks really fun? We do workshops, so you can present a workshop, you can come to workshops, you can help us plan, you can be a helper at a workshop. There's a lot of different ways to get involved in Maptime Davis, as well as UC GIS week. So if you're interested in planning, get in touch with us on Slack and we can get you on the list to help out for next year. So that is the long list of talking. Let me go ahead and get rid of that. You can see my desktop for a second while I look at my notes. Stop my share. Okay, so before we get into today's materials, I want to do a little bit of practice for, we've got folks coming from everywhere today to this workshop. And I realized that not everyone may be super familiar with Zoom. If your work, for example, or your organization that you work with uses other tools, this may be a little new. So what I'd like to do is make sure that you understand where things are before we get going. One important aspect of this workshop will be using the chat. So if you have questions, something's not going right, you want to ask me something, you're going to use the chat function. So on Zoom, if you look down at the bottom of your screen, there's a there's a menu. Look for that chat button. It looks like a little speech bubble in a cartoon. And if you open that up, you will see the chat. You can type in the bottom. Make sure that it is set to everyone. And let's go ahead and introduce ourselves. So if you can type in the box, if you would like, tell us your name and where you're coming from so that we can get an idea of who everybody is. This is optional, but it's kind of a nice way to see who's here and just say hello. So go ahead and put, if you don't mind, put your name and where you're coming from. It could be, your location, or it could be where you work, what you do. Just quick introduction in the chat would be really nice. Awesome, thanks, folks. I can see lots of messages coming through the chat, and I appreciate that. Seeing folks from a lot of different California places, but also out of state and international. So that's very exciting. I'm glad everybody is here and making the time for this. While you do that, the other thing that I find useful while I am teaching workshops, I will, given the number of folks, we're going to use the reactions function in the Zoom window. So again, if you go down to your menu on your bottom of your screen, you'll see a button that is labeled reactions and it has a little smiley face. If you click on that, you will see that you have some options. What I'd like to have you do is answer this question. So how many of you are new to GIS entirely? If you are new to GIS, go ahead and click the green check mark. And if you are not new to GIS, go ahead and click the red no X. So I want to get an idea of how many folks here are new to GIS entirely. So it looks like we're about split fairly evenly, new to GIS versus not. So that is, that's good to know. We are going to start from the beginning, so don't worry about that if you're brand new. Okay, so the next question I'm going to ask you, so I'm going to clear out your feedback. The next question I'm going to ask you is, who's new to QGIS? So who has not used QGIS? If you're new to QGIS, click the green check. If you've used QGIS before, go ahead and click the red X for no. So it looks like the majority of you that are responding are brand new to QGIS, which is great. For those of you who are not new, hopefully you're here for a refresher or to learn some new things, and that is also perfectly wonderful. All right, so thanks for doing that. I just wanted to get that out of the way so we get a little bit of practice for how I'm going to be using Zoom today. All right, so I'm going to go ahead and paste some links that I promised you in the chat, and then we'll get going. There's quite a few things in here. So the stuff I just pasted in the chat, we've got the link for those of you who are wondering about where the videos happen. I've got the link to where we put the Map Time Davis videos and on the Data Lab website. There's also a link for Data Lab office hours, which are available to UC Davis affiliates. So if you ever have questions and you're at UC Davis, you can come chat with me on Wednesdays. There's also the workshop materials there, which we will be working from. And then I also have the link for UCGIS week in case you're interested in seeing what else is going on this week with that. So again, a lot of things going on with this group of people. Okay, so let me go ahead and share my screen. Okay, so, and I will make this bigger. These are our workshop materials, and I pasted the link again in that list of links in the chat. Sorry, I need to, every time you unshare and reshare your screen, Zoom turns off all of your peripherals, like all of the participant window and chat and all that. So I got to get that back. Okay, so these are our workshop materials. Again, they're linked in the chat for you. This is what we're going to be working from today. This will stay online. I leave these online basically forever and just update them, you know, the next time we do another workshop. So in the materials, you can see this is the 4th version of this workshop that's been recorded. I've taught it a few more times than this. So, but if you're really wanting to review things and watch along with the video, this one from 2020 is really similar to what we're going to be doing today. In fact, the QGIS North America one is a lot more time. It's slower paced than we're going to go today. So you can always review there. And 3.14, the version is not much different from 3.16, which is what we're going to be working with today. Okay, so in preparation for today's workshop, if you'd like to follow along, we are going to be using QGIS version 3.16. If you installed 3.22, because that's also on the website, that's fine. It will work just fine. I will mention that this week, QGIS had a little bit of a challenge with some updated versions of version 3.16. So just be aware, we may see some challenges going on, but I don't anticipate running into anything today with what we're doing in the workshop. However, if you have 3.16 on your computer, I would recommend on Friday, they are releasing an updated version of that. I would recommend on Friday or maybe next Monday, next time you're at work, just go ahead and update and that will solve. They have a bug fix in the works for what happened with that, which is one of the advantages of open source software. When something goes awry, it's a little bit quicker to fix. And also the data that we're going to be working with is available on a box folder online. You can grab that. There is I'll mention this again when we get to the data part of this. There is a button up on the top right-hand side of your screen. When you go to that box folder, that will let you download everything at once in a zip file, so you don't have to download all the bits of the shapefile one at a time. There might be a little banner sometimes that pops up. You can dismiss that, and then you'll be able to see that download button. So I'm seeing in the chat, will it work if we have an older version? Yes, it should be fine with an older version. When I updated this and went through the workshop from the last time I taught it with 3.14, there was very minor updates. So it should be, I think there might be a couple of menus that are slightly different wording, but the functionality is all going to be the same. So you should be fine. Again, don't download a new version right now. It'll take about a half an hour on a quick connection. So just work with what you've got or sit back and watch it. It will be fine. Okay, so today's workshop aims. We are going to start from the beginning. I'm going to assume you have no prior experience with QGIS or GIS in general. So if you have some of those skills, great. But if not, don't worry. We're going to start from the beginning. And the point of this workshop is really to get you the fundamentals, enough language and understanding to be able to effectively learn on your own after this. So our learning objectives today are to define some terminology, to get to know the difference between raster and vector data, because those are the most common data types you'll see. There are other data types, but these are by far the most common ones you'll work with. We're going to learn how to work with a QGIS project. These are all pretty standard GIS-y kind of things. How to look at attribute data, do some selections, do some symbology, and how to make a basic map. So that's the plan for today. We will get through as much of that as we can. So do I have any questions before we move on? I think we addressed the one question that I saw come up in the chat. All right, so I will keep my eye on that and I'll let my helpers interrupt as needed. But okay, so we will jump into concepts. What is GIS? So it stands, the letters for GIS stand for Geographic Information System or Geographic Information Science. People don't really make a distinction between those two. They just say GIS, but Geographic Information System typically refers to the software like QGIS that we're going to work with today that helps you create data and investigate spatial relationships between your data. When we talk about geographic information science, that's more the framework of how we ask the questions and investigate spatial relationships. So you can see that they're very closely related and no one's going to make the distinction between doing information systems versus science. So we just say GIS. But again, we're academic here at Maptime Davis, so we got to do some theoretical stuff. So what is QGIS then? So QGIS is a software. It's a graphical tool. It has a graphical user interface. Sometimes you'll hear people pronounce that GUI, which is kind of fun. But QGIS, if you go to the website, at least at some point, it said that QGIS is a user-friendly open source geographic information system, GIS, licensed under the new general public license. QGIS is an official project of the Open Source Geospatial Foundation. It runs on Linux, Unix, Mac OS X, Windows, and Android, and supports numerous vector, raster, and database formats and functionalities. That's a lot. And that, it is a lot. So let's unpack some of this. Most importantly, QGIS is a desktop GIS. This means we're going to be working with a thing that has a Windows-like environment. We're going to have windows and interfaces to fill out. It is a very visual interface. And again, it has a graphical user interface, which sometimes people pronounce GUI. It is an open source project. That means that you can actually get the code that makes this product happen, and you can modify it if you want to. You don't have to, but you could if you need to. And the advantage to that is that it means anyone can make fixes. So if, for example, something goes wrong, like something happened this week where things were not quite running the way they should, it means anyone can go into the software and find the problem. And if they can fix it, they can do that and they can contribute it back. I have to say, I was digging through log files when something went wrong with my software yesterday. And it was very nice to be able to know exactly where I could go look at that code if I needed to. I don't generally have to do that, but it's nice to know if I really need to, I can. And also it means I can see exactly what the code is doing for research purposes. And the last little bit I want to talk about is the part where it says QGIS is an official product of the Open Source Geospatial Foundation, which is also, we call it OSGeo. So full disclosure, I am actually a board member for OSGeo. I have a 2-year term and I'm in the middle of that right now. So we've got another year to serve. OSGeo is an organization that supports open source geospatial software, and it provides some of the things that these projects need to really run smoothly. So we have communication tools, fundraising functions and things like that help support these, and also just a lot of all the support that software needs. That's sort of the goal of this organization, and it's a nonprofit. So just so you know where it's coming from, this is not the same as, you're probably familiar with some of the proprietary softwares out there that are run by a company that is for profit and is structured that way. This is a completely different structure in terms of the business side of it. So if you want to get more information, I highly encourage you to check out OSGeo. I think it's pretty cool. So why QGIS then? What's the advantage to this software versus some other tools you may have worked with in the past or heard of? There are a lot of desktop GIS products out there. some of which you've heard of and some of which maybe you haven't. But QGIS is robust. It's powerful. It does everything I need it to do as a GIS professional. It may look a little different, and you may have to get at things in a different way than you're used to if you use other softwares, but by and large, it does everything you need it to do. One of the major advantages is that it runs on Mac, Linux, and Windows. So you don't have to have a separate booting system for Mac or anything like that. It runs natively. It's also free of charge. You can download the software for free. Everything is free. There are no paid add-ons or extensions or things like that. It is open source and free. Also, there are frequent updates and bug fixes, like coming Friday. There will be an update for QGIS for version 3.16, and 3.22 is looking pretty good. There's also really great community out there, very responsive. I actually found out about some of the challenges and what the problems, like what the explanation for the problem was via Twitter, which was really nice. I actually was fixing some things this morning to make this workshop run more smoothly based on community help. So that's really nice to have that support. It also integrates really well with things like R and Python and PostGIS. If you don't know what those are, don't worry about it. But if you do know, you're like, yes, that's so awesome that I can connect all these different programming and database tools natively. It also works with established software projects like GRASS and Saga and Orfeo, which isn't on that list there, but these are tools that do specific things that you might want to tap into. And so you can connect to those with QGIS and not have to run something separate. It also works with open formats really well. It comes in more than 40 languages. So if English is not your first language and you want to work in something else, you can download a language pack and translate your QGIS to work with that. That's really helpful when you're working with an international community or collaborators. And also there's growing use by local, state, and federal and international government organizations too. So you are in good company if you're working in QGIS. So I see a question in the chat about, would it be easy to move a project between ArcGIS and QGIS? Do they play nice? So there is a project right now to be able to port ArcGIS project files into QGIS. However, I would say your best bet is to just transfer your data over, because the data that works in ArcGIS largely works in QGIS. I'll put an asterisk on that and say that sometimes the proprietary formats, because they're proprietary, have not been able to be transferred into an open format. It means having to break into a proprietary format. So as long as your data is in something that works well for Exchange and is well known, like shapefiles work in QGIS, we're going to work with that today. The open formats work really well. So as long as, I would say, just stay away from like the like personal geodatabase kind of situations from the Esri products, and it should be fine. Those, you can import those, but it's a little less smooth, which makes sense because it's proprietary, right? It's supposed to be locked down. So I would say bring your data over and play around with it. And after today, you'll know exactly how to do that. And you'll see it's not that much different from what you're used to if you're working in other tools. I see Alex has got some other stuff in the chat, which is great. Okay, so any other questions before we move into some data types and talk about some of our data formats? All right, I'll keep an eye on that chat and we will forge on. Okay, so I promised you today we are going to talk about some of the most common formats of data, and you'll see these when we get to the hands-on portion. So the two most common types you'll see are raster and vector, and I can just make this a little, oops, trying to change the size, and it is changing the size of my Zoom chat instead of the browser. All right, so that's a little bit, you can see everything now. I'll zoom back in a second if it's needed. Okay, so there are two different types of data. You'll typically see raster and vector, and they're good for two different things, or a couple different things, I guess. Vector data is really good at representing discrete objects. So vector data typically comes in the form of points, lines, or polygons. So you can think about different ways that you might work with that. Typically, if you're like, if you've ever like hand drawn a map for someone, like how to get to your house or how to find the coffee shop, you know, near the office, you might draw on a piece of paper really quick. That is typically what we think of as vector data when you're drawing points, lines, and polygons. Like here's the line for the street, and here's the polygon for the building where the coffee shop is, and here's a little star for where my favorite, you know, spot around the corner where the secret table is. That's vector data, so points, lines, and polygons. It's great for discrete things like roads and buildings and things like that. It can represent continuous data, so you'll see in my little diagram here, we have contour lines. Things like topo lines and, you know, isotherms for weather can be represented as vector data, even though it's continuous data. Things like temperature, where you can have a measurement everywhere, could be 1.1, could be 1.2. So we can make these vector lines represent that. Obviously, it's discretized, it's chunked up, right? Like, so it works, but it's not quite the same as representing an actual continuous field, but it can be used in this way. On the flip side of that, we have raster data, which is really actually great for representing continuous data, because raster is, you can think of it like a big piece of graph paper, and every cell in that graph paper, every little square, has a measurement associated with it. So it works really well for continuous data because we can have a cell that can contain any number. Like it could be 1.0, it could be 1.1, it could be 1.11. It doesn't have to have any particular value, although we could limit it. It could contain anything. On the flip side, you can use raster data to represent discrete objects like roads and buildings and things like that, but they kind of get a little funky. It's like if anybody out there does cross stitch, if you've ever looked at a cross stitch pattern really close and you're like, that doesn't look at all like the thing I'm stitching. That's the same situation. You have to chunk it up and break up a building, for example, into a series of grid cells. It can work very well depending on the scale, but it also can be a little bit problematic. So vector and raster have advantages and disadvantages depending on what you're representing and what you need. So we'll see both of these today. We're going to be working with vector data for roads and trees and some polygons for earthquake hazard zones in San Francisco. And then we're also going to be working with a digital elevation model, which is raster data. So elevation is a continuous field, right? You can have anything in terms of elevation for height. So we'll see some examples of that. I'm pretty sure I've talked about all those different things down there. All right, so are there any questions about raster versus vector data before we get into the hands-on portion of today? So you can go ahead and type any questions you've got in the chat. But like I said, we're going to see how these work today as well. All right, so I will, again, I'll keep an eye on that chat window, but I think we'll forge on since I'm not seeing anything come in. All right, so what I'm going to do is I'm going to switch over in a second to showing you QGIS on the screen, and then I will switch to, I'll still be working on the same document you see here, but I'm going to have it on my other screen because I can't show everything at once. So I see a question in the chat. For more of the humanities, do people map more raster or vector data? You know, Melinda, it really depends on what you are interested in working with. I would, if I had to pick one, I would say probably vector data would come up more in the humanities, just because I'm thinking like, you know, discrete objects might be more in the vein of humanities, but I'll challenge my helpers to think of a more in-depth answer to put in the chat. If you can think of anything, like one of my favorite examples is a site that no longer exists, but it was called Placing Literature. It was a project that mapped real world locations in fictional books. That was definitely vector data because it's locations of like, they had a bunch of point locations. But I'll think about that if I think of something else, but I bet Alex and Naomi might have some ideas too. So hopefully that helps a little, but I'm going to hedge somewhat on that answer. All right, so today, like I said, I'll switch over and show you QGIS and the share screen, and I'll move this material over to my other screen, but I will be working off of it, so you can keep yours open as well if you want to follow along. All of the things we're going to be going through are in this document that I have here on the screen right now. So today we're going to download some data. It is available in this link from Box, and so I'll open that and show you what that looks like now. So, and actually, I'm going to start turning off my screen because otherwise it's going to have my image right over some of the more important things. So I'm going to go ahead and turn that off. But I'm still here. Hopefully you can still hear me. When I go to the Box folder, which is linked here in the workshop materials in the download data section, when I open it up, this is the site it takes me to. It's giving me this little warning. You, depending on what kind of Box account you have, you may or may not see this. If you have this banner in the way, just go ahead and click close. You don't need to be logged in to download the materials. And then there's this download button here in the upper right hand corner. If you click that download button, it will download a zip file for you. And then it will, that way you don't have to download each of these pieces of data individually, because we're working with shapefiles. And if you're familiar with shapefiles, you know that they come with all of these multiple bits that need to stay together. So if you click this download button here in the upper right corner, you will get everything at once. So when you download that material, you will need to unzip it. You want to put this data in a place where you can find it again. I have to say, one of the more common questions I get from folks is, where did I put my data? And that's something I can't answer for you. So you pay attention to where you put it so you can find it again. So I have my data stored in my computer in this path. You can put it wherever it is you can find it again. You'll have the zip file when you download it. And you're going to unzip it. I've already unzipped mine just in preparation for the workshop to make sure it's all there. But you will right click and you can, I have 7-zip, but you can also just use your native unzipping tool to unzip that file someplace where you can find it. All right, so I'm going to ask a question for you in using your participant tool, your reaction tool. In Zoom, go ahead and give me the little green check mark if you have got your data and you've got it unzipped. And if you haven't yet and you're still working on it, go ahead and click the red X. If you are not planning on doing that, just don't answer and we'll go from there. So if anyone needs another minute or so to get the data that wants it, go ahead and click the little red X in your reactions button and we'll give you a second to get that. In the meantime, while you're doing that, I'll talk about what this data is. So the data we're going to be working with is data from the city of San Francisco. This is real life data that came from their open data portal. So we've got a digital elevation model of the city of San Francisco. So this is raster data. It's a grid of elevations. And you'll see what that looks like when we load it up. We also have some vector data. We've got some streets. We've got the tree data from the city. We've got seismic hazard zones. And then we also have the boundary of the shoreline. And again, you can download that data with the link here. All right, so I think we're probably good to go to move on. So I'm going to go ahead and move my instructions over to the other screen. You can keep them open if you want to follow along because this is the materials I will be using. So to get things a little bit rearranged. Okay, so first thing we're going to do is we're going to start QGIS and we're going to open a new project. Depending on what operating system you're on, you may do this in a different way. In Windows, right now, what I end up doing is clicking on the Windows button and just searching for QGIS. And I'm going to start up QGIS 3.16.11. Yours may be a slightly different number, and that's fine. I also have 3.22 installed, which will also work for this. So you're going to go ahead and start that up. I'm not going to start it because I've already started it, but go ahead and click and I'll show you what this looks like once you get it going. So when your starts up, your QGIS will look something similar to this. If you've ever worked in QGIS before, you may have some projects down here on your list of things you've opened before, and that's fine. Otherwise, if you're brand new and this is the first time you're opening it, it will probably look more similar to what I have. But either way, it's fine. It may also take QGIS 30 seconds to open up completely, and that's normal. It's a pretty big program. Also, I will tell you that while you're running Zoom and QGIS together, that's pretty intensive for your computer, so it may run a little bit slower while you have Zoom going. Mine may actually also run a little slower, we will see, but when you turn off Zoom, it behaves a lot better. There's a lot of graphics going on here with Zoom and QGIS, so just be aware of that. QGIS behaves a lot better when you're not using Zoom. Okay, so that being said, let's go ahead and get started. So we've opened up QGIS. What I want to do is start a new project. You can either click down in the part that says start a new empty project. You can click up here in this tool that looks like a little blank page. You can go to project and click new. I'm going to click on the project menu and click new because that's the easiest way for me to tell you where that is, because menus move around. But again, I'm going to the project menu, I'm clicking new, but again, there are other ways to do that. So here we go, we have QGIS open. You may or may not have your layer styling panel open. Mine might be remembering from previous instances, even though I thought it wouldn't, but maybe yours is open, and it doesn't matter because we will add that when we need it. So this is QGIS. If you work in other GIS software, this looks familiar, doesn't it? You have a place over here on the side where our layers are going to show up. You have this big open section in the middle where our map is going to show up. And then this browser panel, just ignore it for now. It's handy for some things, but we probably won't be working with it today. Okay, so we have opened QGIS and we've started a new project. Now we're going to load some data. And the first thing we're going to load is raster data. And I don't think you guys can actually see it, but have you ever tried to do GIS in a Zoom window? The Zoom controls are always in the way. So I will be fuzzing with that. Okay, so what we're going to do is open up our data source manager. On your menu, it looks like this. And if you hover over it, it has a little tooltip. It looks like 3 cards, blue, yellow, and red on top of each other. I believe we can also get to this if we click on the layer menu. It's the first option in the layer menu. Just know when I point to tools on the toolbar, yours might be in a slightly different place depending on how big your screen is or how it decided to load. So I'll try to show you things in the menus because they're a little easier to find. So again, I'm going to click on Open Data Source Manager. So this is a slightly different way of loading data if you're used to other tools that you've used, but I'll show you how this works and then it will become second nature. I'm just going to expand this a little because my screen size changed and it changed the size of my windows. Okay, so we want to load raster data. The first thing we're going to do is load up our DEM. So I have all these options on the side for different types of data. This is why I wanted to tell you about raster versus vector data, because you need to know what kind of data you're loading. So I'm going to click on the raster option here on the side panel. So again, I'm clicking on raster because we're loading digital elevation model data. If you pick the wrong one and you try to load, like say I try to load vector data in the raster data thing, it's not going to end the world. It'll just tell you it doesn't know how to read it. And then you'll be like, wait, what? And then look and make sure you've clicked the right thing on this menu on the left side. Okay, so now I'm going to load data. I'm going to click on this 3 dots button over here on the side to navigate because I don't want to write out the path in there by hand. So I'm going to click browse. And now what I want to do is I'm going to go and navigate through my computer and find where I stored that data. So I put my data in this folder. Yours will be called probably something different. And then this is my folder that has my data in it. Yours might be named similarly if you just unzipped it. Okay, so what I want to load is just my TIFF data. A TIFF is a raster format. It's an image. If you've ever played with photos that you've taken on a camera, for example, a digital camera, you may have downloaded a TIFF before, or you may find those on the internet too. So it's standard format for images. This happens to be a GeoTIFF, so it has some geographic information in the headers that you won't see, but it's there for the GIS to read. You also notice there's an auxiliary file. Just like other GIS softwares, we don't need to tell QGIS about the auxiliary files. It will find it. So we just need to click on the dem_sf.tiff, and then we're going to click open. And it loads it up here. And in some of these options, some of the formats, there'll be other options, so it doesn't load right away. But this looks good, so I'm going to go ahead and click add. The thing that pops up is it wants to know what transformation I want to use for my projection. Projections are much bigger than we're going to have time to get to today. So for now, I'm going to say you can click with the default. It's probably good enough. You can see accuracy is 4 meters. I think I put in the workshop that I'm just looking for which one. Number 43, I think. Anyway, for the workshop purposes, it doesn't matter which one we pick. I'm not seeing the one that I wanted to use, probably because I've loaded a bunch of things. So I'm just going to go ahead and click this first one, the NAT 83 to WGS 84, and tell it OK. You definitely want to think about those things, though, because it can change some of your accuracy. But I'm just going to slide this guy out of the way, this window, so we can kind of see we've loaded our data. It looks roughly like this is the San Francisco Peninsula. It's can't really see the shoreline very well yet, but we will play with the way that this is displayed later. But it loaded our data. This looks good to me. It's just not styled in the way that I want it yet, but we will be doing that later in the workshop. Okay, so that's loading raster data. Next we want to load some vector data. So if you left the data source manager open, great, we can work with that. Otherwise, you can go back to the layer menu and pick it off the list in the layer menu to reopen that. So I want to pick vector next. So what we want to do is, again, we picked our format here on the side. So we picked vector data, and I'm going to click on my 3 dots button here to browse to find my other data. So I'm going to load up my shapefiles next. The cool thing is I can pick, so I'm going to start with my list. I'm looking for the .shp extension. So I want to pick this seismic hazard zones.shp. And I can also hold down Control and click my other ones to pick multiple files at the same time. So I've got my seismic hazard zones, I've got my shoreline.shp, and then I've got my street centerlines.shp. I think I'm looking at the notes and making sure that's all the ones I need. So those look good. And again, QGIS will find the auxiliary files that it needs. We just have to point it to the main file. In this case, it's a shape file, so we want the .shp. So I'm going to go ahead and click open. And you can see that if you look at this path, there's actually 3 different paths listed there. So if you want to type paths, you totally can, but I would spell something wrong. You have options here. For example, the character encoding can be really helpful to note if you're working with data that uses a different character encoding. I think the default is UTF-8. So if you're working with something else besides UTF-8, you'll want to put that there, but that will be fine for us today. And then the other stuff is things we don't need to touch today. So I'm going to go ahead and click add. And again, it's going to ask us what transformation we want to use. I made note of one that you can pick if you want. So I think I said to pick this one that has the parentheses 43 at the end, but any of these will work for the workshop purposes. So I'm just going to pick that one, the one that's numbered 43 at the end, because it has minimal distortion and it's for North America. So you can see, again, my data source manager didn't move. It didn't go away, but if I slide it out of the way, drag it so that it's not on top of everything, you can see I've got some data loaded here in the map. It's kind of in a funny order, but we'll deal with that later. But so our data loaded, which is great. The last thing I want to add, I'm going to slide my data manager back into the main window here. The last thing we want to add is our CSV data. It's really common to get spatial data, especially point data in a CSV, a comma separated variable or comma separated value. I've heard both. I'm not sure which is right. So that it's a really common way to get data. So we're going to work with that today too. The way that we do that is we pick this option here on the left menu for delimited text. So this is CSV is okay, it says comma separated values here on our list. This means that all of our data, it's like a text file, but in between each of our values is a comma. If we were to open it in a text editor, we would see that. There are other delimiters out there, like tab delimited is pretty common. My favorite is actually pipe delimited because nobody types pipe, so it's not going to cause a problem. But if you use a comma, for example, you can end up with problems if you have natural language because people write with commas, and that can sometimes cause problems. Things are getting better where they can kind of work through that, and the computer can parse that even if it has some kind of random commas in there. But if you're going to be working with data that might have commas in it, you might want to pick a different delimiter, and you can do that here for custom delimiters. But ours is a CSV, so we're going to leave that. What I do need to do, however, is tell it what file I want to use, which is way at the top here. It's in this version, it's a little hard to see, but I'm going to click on the navigate button here. Again, the 3 dots button over on the side next to file name. And I'm going to pick my streettree.csv file because it has our street tree data, and that is the CSV for today's workshop. So I'm going to click open. Again, we want to look through the menus and make sure we're picking everything we want. So it is a comma separated file, so we're going to pick that. I don't think we need anything in this records and fields options. We're going to leave that all the way that it is. We do want to take a look at our geometry definitions. Right now it's set to no geometry, which in mine, yours may look a little different. That's really good if you don't have anything in there, you just need to bring in a table to join with something else. But we actually have point coordinates. So I'm going to pick point coordinates. And then it'll guess based on names of your fields what one you want to pick for the X and the Y field. I think it picked correctly, so we're good. But if you need to change that, you can click on the drop-down menu and pick a different option on your list for it basically lists all of your columns in your table. And then down at the bottom, I'm going to make this a little bigger so you can see this. It previews the data, so you can get an idea of if it's parsing correctly. Like maybe I picked the wrong delimiter and it isn't making columns, it's just making one big blob. Then it tips me off like, oh, hey, I need to go look and make sure that I picked my right file format. But this looks good. We will explore more of this later, but I'm going to go ahead and it's not letting me add. Oh, it's telling me the CRS has to be selected. Thanks, Naomi. So I missed the one important thing right now. I left this geometry CRS option here. Mine says invalid projection. What I want to pick is WGS 84. If yours doesn't have that on the drop-down menu, you can click on this button here that looks like a globe wearing a little cone hat and hanging out with a carrot. What that is actually, it's a conic projection. So it's wearing a cone. Because that's how you make conic projections. You put a cone on top of a globe. So what I can do, because I know I want WGS 84, I can either search in the box here with looking for that text, or I can give it the EPSG code, which is 4326. So if you type 4326 in the filter box, you can make sure that you get WGS 84, which is the projection our data is in, and we're going to go ahead and click OK. And now it should let me add. It does. So I'm going to click add. And this file is kind of big, so it might take a second to load on your computer. Oh, mine loaded pretty quick right now. It's already there. As it reloads, sometimes it looks like little ants marching on the screen, which is kind of fun. But so we've loaded all of our data now. We just added our CSV of street tree points. So I'm going to go ahead and click close in my data source manager because we don't need that anymore. All right, so look at that, we have loaded data. So this is, I think, one of the more challenging things for folks coming from a different GIS system. If you're familiar with other software, is how do I load data in QGIS? This is the hard part. We've done it. So the rest of it will look pretty familiar if you're familiar with other GIS programs. All right, so I am just checking out the chat and making sure helpers feel free to chime in if I miss something important. Okay, so the next thing we want to do is find out how to save, because as with all programs that are large, it is a good idea to remember to save. So what I want to do is I can either click on this blue floppy disk. If you are on a different operating system, you may have a different download button. Some in Linux, for example, it looks like a little arrow pointing down. In some Windows, not all. So just be aware your save button may look different. But you can also go to project and click save. So project menu and then pick the save option. So I'm going to do that. And what I want to do is I'm going to navigate to where I want to put it. So I'm going to put it in my workshop folder for today. And I'm going to give it a name. Spell that right, workshop. So I'm going to call mine QGIS workshop. It's going to give me the option for saving which type. Just leave it as QGZ. The other option is QGS. Either one is fine, but QGZ works just fine. It's the zip version, but it's the right way to go. So go ahead and click save once you've found where you want to put it and you've given it a name. And now every time we click the save button, it will save our changes to that file. And so that's how we save. We're going to try to remember to make sure that we save as we go, because like any big program, it can crash. It's pretty stable, but occasionally, especially running Zoom, it may have some challenges just because of computing resources. So, or if you have some other things running and you're trying to do QGIS, you've got a higher likelihood of crashing, just like any other big program. So we're going to save a lot. Okay, that being said, we've got everything loaded, we've saved. So if we have a problem, we can come back to this point. And now let's go ahead and jump into working with some raster data. Okay, so I mentioned this earlier. Over here on the side, on the left-hand side, we have our layers panel, and it lists all of the data that we have worked with previously. Yours may be in a slightly different order, but it's making me a little bit crazy that my street center lines are underneath all of the polygons. So if I want to move that, I can just click on it and then click and drag. And it's subtle, but there's a little line that shows up and it shows me where it's going to put it if I drop it. So when I release my mouse, now I have my street center lines on top of everything. This is vector data, and we're not going to work with that right now. So I'm going to go ahead and turn it off. I'm just going to uncheck the boxes next to my points, lines, and polygons. You can see a little preview here for points, lines, and then 2 polygons. That way I can see my DEM. We could also move the DEM up to the top, the digital elevation model, but later on it'll be nice if it's lower on the list because you can't see through a DEM. So I like to put those on the bottom. Okay, so this is the file we're going to be working with. It's a digital elevation model of San Francisco, including the ocean. So we'll be trying to get the coastline to show up a little bit. So again, this is raster data. So it's made up of a bunch of little cells, like you can think of grid cells, and inside each of those grid cells is an elevation. There are ways to show that, but we'll skip that in terms of time. And what we want to do, we're going to work mostly with styling. So what we want to make sure we have open is this layer styling panel. Mine is already here, but if yours is not showing up, I'm going to click over anywhere in the blank toolbar space. I'm going to right click, and then I can choose what panels show up. I want to make sure that layer styling panel is checked. I'm going to show you that again. So I'm going to click in my toolbar, any place where there's a blank spot on my toolbars up here. I'm going to right click and make sure layer styling panel is checked. So that way you see this. I'm also noticing I've got a lot of real estate for tools, so I'm going to drag this one and just get it out of the way and give it just a slight bit more space. Okay, so I've got my layer styling panel loaded, and I'm going to, if I hover over the edge, I can expand it if I click and drag. That way you guys know how I'm making this happen. What I want to do is make sure that my DEM is selected over here in the left-hand side so that my layer styling panel is showing the DEM. You could also change this drop-down menu as well, but this is how I like to do it, so that I'm showing you both. Okay, so what we want to do is make this DEM look more like I want to say more useful, because right now it's not really showing me what I expect to see when I'm thinking of elevations in a coastal area. I really can't see like where the water ends. Why is this? It's just really low elevation, and it's displaying it as kind of together with the ocean. So I want to play with this and make this look a little bit better. Okay, so we are making sure we are clicked on our Symbology tab, which looks like this paintbrush painting a rainbow if you get really close. So it's the first option on this little list of buttons here on the side. So I'm going to make sure Symbology is activated. It'll look like this. What I want to do is, right now it's displaying it as a single band gray image. So it's going grayscale, and it's looking at one band. We only have one band in this. If you have like a color image, you'll have red, green, and blue bands. If you're working with remote sensing with like multispectral, you'll have many other bands. But what we want to do is change it to single band pseudo color. So we're going to work with one band, but we're going to give it a different color. And if your data just disappeared like mine, don't freak out. It's fine. It will get it back. It just doesn't know how to display it, so it turned it off. But again, I picked single band pseudo color from this dropdown instead of the gray one. And now what I want to do is we're going to change some of these values over here, some of our options, and then our data will look a little bit better. So for the render type, it says, okay, oh, sorry, we already did that. We picked single band pseudo color. I'm just looking at my notes and making sure I got everything. So I want to expand this min max value setting, and I want to tell it, I want to have it pick the whole raster. So if it had something else, make sure it says whole raster here for the statistics extent. And for the accuracy, I'm going to tell it to do actual in parentheses slower. What that's going to do is it's not going to sample, it's going to look at the whole data set. This is a small data set, so we can do this. If you had a big global data set, you would want to let it sample. And then for the color ramp, this is how we make the data show up. Not seeing what I'm looking for. Here we go. So down here, kind of in the middle-ish, just below middle of the interface, I'm going to pick my color ramp. So I'm going to click on that little drop-down menu. And I actually want to tell it, I'm going to create a new color ramp. And once I pick create new color ramp, it's going to give me options. I could make my own, but if I pick catalog, it will let me look at the list that's already been created to pick from. So I'm going to pick this first catalog option called CPT-city. So off that menu, again, I'm picking CPT-city. And I'm going to click OK. And that's going to open up this menu with a whole bunch of pre-made color ramps. And you can see in the background here, it loaded the first one. And this is not what I want, but at least now I can see my data, so I feel a little bit better. So from the list, what I actually want to do is you can look through all of the color ramps, which is what it's on now, but I can separate out for topography. I'm going to actually click on that because it narrows down my list. And the one that I want to use today is called, I think I know which one, but I'm going to tell you the right one and look. I want CDA. So this one here, it's kind of, on mine, it's in the second row. Depending on how big your window is, it might be in the first or third or fourth or whatever, but this one called CDA. And you can see the preview down here. It's a nice gradient of different colors, including blues for water, which is going to be helpful since we're in a coastal area. So again, I'm picking CDA from the topography menu. I'm going to go ahead and click OK. So these are predefined for us, and with the defaults, it's still not looking great, but we're going to keep making some changes until we get what we want. So also down here, a little quick tip is there's a button here for live update. I'm going to have mine set to live update, but if yours is being slow, you can turn it off. And then as I scroll down here, there is a button for apply. I guess I didn't need to scroll, that stays on there. But anyway, so the apply button will update if you turn off your live update, but otherwise, if it's checked, then it'll keep updating as we make changes. So sometimes it can be useful to turn that off if I need to make a bunch of changes on a big data set and I don't want it to try to keep updating as I'm making minor changes and I just want to do them all at once. But for today, we're going to leave that on, at least I will, so you can see what's going on. Okay, so we're back in our layer styling panel. We've got to make some changes to this because right now it has two classes, it's continuous, and this is not at all what I'm expecting from a digital elevation model for this data. So in the styling panel, I'm going to change my mode. Instead of continuous, like right now it's stretching between blue and white. I want to pick, what did I say I want? I want discrete, I'm looking at the wrong thing. Okay, so sorry, I'm in the wrong spot. So for the interpolation drop-down menu, right above your color ramp, instead of linear, I'm going to pick discrete. So it's going to make it into, you can think of bins like a histogram. Okay, this is already a little bit better. And I want to, for the mode down here, instead of continuous, I want to do equal interval. And that, again, we're going to fix all this. So don't worry as it's changing and kind of looking a little bit wacky. We will make this look better. Okay, so again, I've got my interpolation method is discrete. So I'm going to have bins. My mode is equal intervals. So my intervals for my bins are going to be the same size. You can play with that depending on your data, but equal interval is pretty intuitive for most data sets. So we're going to go with that. And then for a number of classes, the default here on mine is 5. I'm going to highlight that and tell it I want 10. You can also click the up and down arrows if you want. So I'm going to break this data into 10 classes. They're going to be equal interval. If you're used to making histograms, this sounds familiar. So we're just binning our data into 10 classes. And then our classes here, it kind of came up with some, and they're not great because again, I can't see my coastline very well. So I'm going to actually now mess with my breaks. I'm going to change them to be the way I want them. So they're no longer going to be equal interval, but it's going to work better for visualizing this data set. We're not changing the data here. We're just changing what color is assigned to each cell. So just be aware of that. We're not changing data. We're just changing the display. So what I want to do is I can type in these boxes for the values. So if I double click, it will let me edit. So if I double click in that box, I can choose my breaks. And I decided that I put in the workshop materials, the breaks that I chose, so you can follow along. So the first one I want is 0. And then if I type 0 in the box and hit enter, oh, that feels a lot better, right? So now we can actually see the coastline because what I told it to do is make this kind of bluey green color, make it go all the way from the minimum up to 0. And 0 is where we expect our coastline to be because 0 elevation is where the ocean starts. So we can see it actually popped out some of these like wharfs and things with some of the coastal structures around the edge of the peninsula. And that's great. We can play with this a little bit. Maybe 0 isn't the best choice for this data set, but for now, this looks good. So we've got actually coastline showing with a little bit of stuff going on the back behind the shoreline, and that's kind of to be expected. So then my next break for the next column, instead of 72, I'm going to double click and I'm going to tell it I want 50 for my break. And these next changes are not going to be as dramatic as the one we did with 0. So I want 50, again, double clicking, I want 75. And all these numbers are in the workshop materials if you're following along. Okay, so then I want 125. I'm going to scroll down here in this and add 175, 225, 275. Scroll down some more. 325 for my next one. And then a 350 for my second to last one. And then my final one, I want to leave at INF, which stands for infinity. So it means that I'm going from whatever my last break was, so up to 350, all the way to whatever the highest value of my data is. Okay, so we've added those breaks in, and you don't have to do all of them for the workshop. This is just to show you that you can type in. So if that's getting tedious, do a couple and then you don't have to do them all. But now you can see we've styled our raster data so that now we can see our coastline and we can get a better view of what the topography looks like on the San Francisco Peninsula. So we've taken our data and we've just styled it, but now it's a lot more intuitive. So that's how we're gonna, oops, I clicked in it and recentered. So I'm just clicking and dragging to move things back to where it goes. So Alex is noting that the ocean has negative numbers in it. And that is true. This data set, you can explore it a little bit more, in particular with this identify tool here. It'll tell you if you click around what the value is. So yeah, you want, if we're going to work with this data for like research purposes, we'd want to explore it a little bit more and understand better what the ranges are. But for the workshop purposes, having our shoreline at 0 is good enough. You definitely would want to understand your data and make sure that 0 was what you wanted if you're going to be working with it for research purposes. Okay, so are there any other questions I should address, helpers?
Actually, I have a quick question. If you wanted to follow up on how you would explore your data, can you open a table with your DEM like you can with a raster and look at the values in it?
Sorry, ask that again.
Sorry, can you open up, where can you view a list of values in your DEM?
Oh, good question. So this is what I was looking at. I was like, where did it go? Sometimes things move around on me. So you can click on this histogram tab. If we're in, I don't think you guys can see my Zoom tools, but they're in my way. So in my layer styling panel, there is this kind of the third option on the list for histogram. And if I hover over it long enough, it'll say histogram, but so I'm just going to expand this a little bit. So I can tell it to compute histogram and it will, you can see the histogram on this one. I don't know why it's not computed the, it's only doing min and max for, let's try adding 350. Maybe this is one of the things that isn't working so good right now with the update. Anyway, so you can look at your histogram when update on Friday, it will probably be better. But otherwise, what I typically tend to do is I actually like using this identify tool up here. It's really kind of simple, but really can be powerful. So if I click on the identify tool, it's like the letter I in a blue circle. Everywhere I click, it will actually tell me what the value is. Here in this table. So I can see for band 1 where I just clicked was 8 meters. If I click here on the ocean, it's telling me that's 0, but there may be some negative values in here as well. So if I click on my shoreline, I may see different values. So that can be really helpful. And then you can also, so I'm going to close this little widget that I've opened with this X here on the side. The other thing that can be helpful is just the statistics that it's calculating. Like it's telling me my min value here is actually negative 9.36. So I know I've got some negative values in there and I've got my maximum is almost 400. So that kind of stuff, kind of data exploration can be helpful. Another thing you can do is you can open these kinds of things in R, which is a whole nother workshop. R and Python can open these files as well, and you can work with them there. So I see I have another question. What is the data structure to see where the elevation values are stored? So these are, I think Alex might, Naomi may have a better way to answer that question about the data structure, but essentially these are under the hood. You can think of them as a giant list of values, and then the specs in the header would tell it how to form it, like how many rows and columns inside. So it is literally just a list of numbers for the raster. I mean, this is a binary format, I believe, so it is binary, so you couldn't open in a text editor for a TIFF, but that's the general concept of what's going on under the hood. There are some other ones that are text-based, so you could actually look at those in a text editor as well. You guys got some good questions for me today. So let me know if you have other ones. So I'm looking back at my notes. Okay, we've got another question, which is good. So someone who says they're new to GIS, wondering what the role of projections play in an analysis. All right, so this is a great question. We're not going to have time to get into the giant world of projections today, but I will say that a projection is the mathematical formula that translates measurements on a spherical surface, such as a globe, to a flat plane, such as when you think of a map or like either a print map or one on your computer screen. So depending on what projection your data is stored in and what projection you want to be using for your analysis, we need to make sure that those match, and you want your data sets all to have the same projection. Today, we're actually working with an unprojected coordinate system. We're working actually in lat-long WGS 84 because we're not doing any like serious measurements, but if we were, we would want to make sure that we were reprojecting our data into the correct projection. So Martin, that's a very vague answer. And I will tell you that we've got some workshops on projections in I've got some materials. So if you want to email me, I can send you some of those, or Alex may be able to dig those up on the transfer over to the Data Lab GitHub repo. But we do have some materials from Maptime Davis that can help you with that. But just know projections are a big topic. So I'm not going to get into that in too much depth today. But there you go. Anyone else who knows projections is like, okay, that's good. We're not doing that today. It's a lot of thinking, especially for an intro workshop. But these are great questions. And I think it's good to acknowledge that we are very much glossing over the concept of projections today. And that's by design, because I don't want to give you too much to think about at once. Okay, so I'm not seeing any more questions in the chat, but again, I'll keep an eye on that. So next up, we're going to work with vector data. So we just did raster data in terms of symbology. We didn't do any analysis or anything, but we did style it so that we could actually see what's going on in our data, which is kind of a first step. The next thing I want to do, I'm going to click the save button. So again, I can either go on the project menu or I can click my little blue floppy disk here. And that saves it. So if something were to happen, I can come back to the stopping point. Okay, great. So we've saved. Now I want to start working with my vector data. And we may just get through this today looking at the time, which is fine because the materials will be up online for forever, as long as GitHub is there. Okay, so what we want to do is we kept our layer styling panel open, so that should be there. But again, if you need to turn it back on, you can right click in your blank space for your toolbars and make sure that layer styling panel is turned on. So we're going to still need that. I'm going to go ahead and turn off my DEM. So I'm going to uncheck that box. And then I want to think, what are we going to work with first? So I think we're going to work with our streets first. So I'm just going to go ahead and I'm going to turn on my shoreline and my street center lines. And then I'm going to use, I've kind of zoomed out a bit. So I can either use the zoom tool here and navigate, but what I think I want to do is I'm going to right click on my street center lines, right click and click zoom to layer. So again, I right clicked on my street center lines and I'm going to click zoom to layer. And that's just going to make it fill up my window there so I can see things a little bit better. All right, so your colors are going to probably be different than mine. Apparently mine is doing earthy tones today. The last time I taught this workshop, I believe it did everything in shades of bright fuchsia pink. So this is a little easier to look at, but we will be fixing this in just a minute. All right, so we're going to work with our street data. I turned on the shoreline just so we kind of have an outline of the peninsula for the city of San Francisco, just to make that a little bit easier, but maybe I'll turn that off later. All right, so again, I'm going to make sure that my street center lines are selected over here so that my layer styling panel is working with my street center lines. If yours is still showing your DEM, you can either highlight that here in layers panel, or you can use the drop-down menu and pick your street center lines. All right, so we want to make sure right now we're going to work with single symbol because we're just going to see how the basic stuff works. So you can see here in our single symbol dialog, we have a couple things. We've got a line and then we've got simple line. So this line here is made up of everything below it, in which in this situation, it's just one line. So I'm going to click on that and you can see it's telling me it's brown. Yours is probably a different color because it's just picking them kind of at random. But I don't know about you, brown doesn't really say paved street to me. Like it might say like unpaved or dirt road, but I want to make this say street. So what I want to do is I'm going to click on this color box right where mine is brown. Yours is some other color. I'm just going to click. It's going to open up a dialog. If you're brand new and you haven't opened QGIS before, you probably have no recent colors. This is apparently the one I picked when I checked yesterday to make sure things were running in this version, but yours is probably blank. What we can do though is there's different options here for selecting colors. All of these have different uses. I like the slidey things a lot of times, so I want to pick a gray. So what I'll do is in value tell it I want gray and then start maybe playing with this. And you can see the color preview down here. The other option, so you can see I'm doing a bad job of picking gray. I've basically made black again. What you can do is look up hex codes for HTML and it can use that. So for example, I'm going to use this one, which is all 6s. So down here in the HTML notation box, I can paste a color. In this case, it's we've got the hash symbol, hashtag, pound, whatever you want to call it, followed by 6 number 6s will give you the color that I am working with. Oh, in this case, it looks like it's a really dark gray. So that's darker than we're going to work with later, but that is all right. We will be playing with that and changing it up later. So you can see actually this one gives me well, I guess it's already all the way black. Anyway, we can change it if we want. We can make it a lighter gray. We could make it pink if we want, for that matter. It's up to us. But anyway, so we've got a gray color here in the box. And you can see that as I'm going, because I have that live update checked, it's changing all of my street center lines to gray. So this works for now. We'll leave it here. We'll play with this a little bit more later. I'm going to click this go back button here at the top that looks like a triangle pointing to the left. And there you go. So that's how we change the symbol for everything all at once. And we'll play with some more options for that later. What I wanted to do next, though, is talk about attribute tables. So the data that we have represented, it's not just lines, right? We actually have information about these streets and other entities that we have in our data set. So vector data, so points, lines, and polygons are typically made up of 2 parts. You have the geometry, so the shape of it, whether it's a line or a point or a polygon, and then and that includes the location. So what shape is it and where is it? And then the other part of that is the attribute information, which is information about each of those entities. So for these roads, for example, I have different pieces of information, like what's the name of the road? What type of road is it? And the way that we see that is we look at the attribute table. So what I'm going to do is right click on my street center lines, and I'm going to tell it after I right click, open attribute table. So that's kind of in the middle of my menu. So again, I'm looking for this open attribute table option when I right click. And what that's going to do is it's going to open up a table. Mine went on the other screen, so I'm going to drag it over so you can see it. And you can actually see, I see Colette's question. So we've got this table here. I'm going to drag the table actually back to the other room, the other screen. So I can answer Colette's question, which is how to get out of the zoom in, zoom out tool. That is not a silly question, Colette. That is a good question. So if you've clicked on your zoom tool or zoom out, the antidote to that is this little button that's called the pan tool. It looks like a little white hand or a white glove. And that tool will let you just click in. Like if I click and drag, I can move stuff around, but I'm not going to interact with things. I'm not going to zoom in or out. one, so Colette says in the chat that she lost her city for a moment. The other thing you can do is you can right click on the data you want and pick zoom to layer in your right click menu. And that can be really handy for recentering things. So if you're new to GIS or new to QGIS, that is a really good question because it is easy to get lost. The other thing to be aware of is your scroll wheel on your mouse will zoom in and out too. So if you bump that, you could send yourself to another state on accident or zoom way out. Okay, so back to attribute tables then. So this is my attribute table for my streets. You can see I have column headings up here. Metadata is really helpful for this kind of stuff to understand what's in here. But I'm just going to scroll to the side and you can see this column and hood tells you what neighborhood it's in. So if you're familiar with neighborhoods in San Francisco, that might be helpful. Let's see, what else do we have? We have things like the street name. So I've got names, I've got what kind of street it is. Is it a street? Is it an avenue? Is it a court? Is it a way? I've got the zip code that it's in. So just general helpful information. There's also a column in here that tells me class code that we're going to work with. It tells us what size the street is. And what I can do also is all of these rows are connected to a particular item in our map. So if I click on something, it will actually highlight. I picked one that's really small, so it's not showing up. Let's pick, maybe if I can find one with a higher class code. I'm just scrolling right now on my scroll wheel. So I bet if I click one, that's too small of a segment. Anyway, I can also click zoom to layer, but so if I click zoom to the item, it's this guy right here. Oh, that's why it didn't show up because it's very small. It's a very small line segment. But so anyway, just to prove that those things are linked. And so I can actually see that this is a freeway. At least it's a portion of a freeway. It's in the Presidio. Oh, it's 101 North, probably on ramp, it looks like, or something related to that. So anyway, we've got every single one of these lines here has an entry in our attribute table, and that's really what I wanted to show. So I made a selection by clicking on the side. If I want to make my selection turn off, I can click this button. It's very small on the share screen, but it is the button that says deselect all features from layer. And if you see it up close, it looks like it has a little red no smoking sign. It's not going to delete anything. Sometimes I have folks in workshops that are like, oh, I don't want to delete it. It's not going to delete it. It's just going to turn off the selection. So again, deselect all features. It's also on your, it looks like this button here on your menu as well. So it's a little bit bigger, a little easier to see. Okay, so that's attribute tables. You can see that there's a lot of information in there and we may want to work with it in a different way. So I'm going to check before I jump over into selecting by attributes. I'm going to take a look at the chat because I see we've got some questions. So is there a way to set a boundary for a map where the area of interest is not easily defined? For example, a UC campus. So that gets into how to represent data. So I'm going to leave that one for now. But yes, that can be challenging where there's not a set boundary. Like if you have a fuzzy boundary, for example, I've been working with historical tribal areas for California with a researcher, and those are not hard, fast lines. So that's really hard to represent, but that's probably a whole nother workshop. So I'm going to leave that one for now, Martin. But that's a really good question. Sometimes our data formats are not well suited to those kind of situations for sure. All right, so next up, we're going to start looking at how to select by attributes. So this kind of starts to get into analysis, and it's going to also help us with some of our styling later. So I can see, for example, I have in my attribute table here, I have this class code column, and maybe I'm interested in finding out some more information about it. Fortunately, this data set does come with metadata, so I can find out what that means, but maybe I'm not 100% sure and I want to check. So what I can do is start investigating it. So I could go through and I could select all of, for example, I could select all of these rows that have class code 1, and I can go through and I can find all of them and pick them out by hand. However, this is a really big data set. I don't want to do it by hand. I can actually sort too. If I click on the column header, and I could do it that way, but you can see how this could get really tiresome really fast with a big data set. So forget doing it by hand. I'm going to use the select features using an expression tool, and I'm going to let it do the selection for me. I'm just going to say, hey, computer, go get what I want and bring it back. So the tool I'm going to use in my attribute table is this tool called select features using an expression. Kind of looks like a scripty E on a yellow sticky note, but it's anyway. And you can see there's a bigger version of it in the workshop materials, so you can get an idea if this is way too small on your screen. So I'm going to go ahead and select features. I'm going to pick that button. I'm going to drag this down where I can see it better. So what we're going to do is build an expression. And if you're familiar with SQL, this is going to look similar. You've done this probably in other, perhaps GIS systems if you've worked in those. Otherwise, it's brand new, and that's fine because we're going to walk through this. So what I want to do is I want to tell it what field I want to look at. So I'm going to investigate my class code field. And rather than typing it out correctly, I'm going to click on this fields and values option kind of in this middle panel, you know, a little ways down. And that's going to open up a menu of all of my column headings. I love this because I type badly and I spell even worse. So if I can pick it off the list, I can make sure it's right. So I'm going to select class code and I'm going to double click, and that's going to write class code here for me. Now, granted, you could write this, but I always forget also which I'm using double or single quotes. Double quotes is for column headings. Text goes in single quotes. So this is really helpful that I can just click and it will do it for me. Okay, so I'm telling it, hey, QGIS, I want to look at class code, but I also want to tell it that I want to look at a specific class code. So I'm looking at mine, and in this fields and values list, I can see my class code. But when I click on it, it's harder to see. My class code, it has this ABC next to it. That means mine decided that when I brought this in, it was text. Yours may be like that, or yours may have a number next to it, like this one right below it that has a 1.2. If it is text, we're going to work with it one way. If it is a number, we're going to look at it a different way, but it's not a big deal. So what I can do is for both options, I can say class code and type an equal sign in my box. So I've clicked here and I just typed an equal sign. If we are dealing with text, I'm going to do single quote, and then I want to look first at class code 1. So I'm going to type a 1 and then put single quotes around it. If yours came in as text, or if yours came in as a number, what you want to do is just type the number 1. But I know mine is text, so I'm going to have single quotes wrapped around my number 1. So once I have that set up, so I have class code equals and then the number 1, I'm going to tell it to select features. And I'm going to move this out of the way a little bit. At the top of my attribute table here, you can see it told me it selected 108. Okay, cool. So I'm going to just kind of slide everything out of the way. I'm going to move this map so I can kind of see. Okay, so it's highlighted for me with this yellow, bright yellow. These are my class code 1 roads. That's pretty cool, right? I didn't have to select all of these by hand. It went through the table and it found class code 1 for me. So now I can start to think, these kind of look like big freeways. And then I can look actually in my attribute table. And if I want to, I can tell it, I can use this button to move all of my selections to the top. So those are all highlighted, that's why they're blue. And then if I look over here at what the street name is, I'm like, oh, this is Highway 101. So, okay, so class code 1 is probably bigger roads. There are things like highways and freeways and things like that. So I can go through and start investigating my data this way. I can come back to my expression here and I can say, well, now I've looked at 1, I want to see what 2 is, and tell it to select those features instead. So now you can see that I've got a new selection in my map, and class code 2 looks like they're kind of bigger things, but maybe not freeways. And then if I look at my attribute table, come here, attribute table, you can see that this is big roads like Van Ness, for example, are class code 2. So I can start investigating my data this way. And I'm not going to spend time going through all of them. I put in your workshop notes what all of the different class codes mean. So for example, 1 is freeways, 2 is highways, 3 is major streets. And again, this was actually in the attribute information, or sorry, the metadata that I got from the city of San Francisco. They've got a really good data portal with actual metadata. So that it's better if someone gives you metadata and tells you what all these things mean, but you can also kind of work with the data and get an idea yourself. Okay, so this is great. I'm going to close my select by expression window for now. And I'm going to close my attribute table because I don't think I need that. I can always reopen it. And I'm going to also clear my selection using this button here. Your menu may be somewhere else, but I'm going to deselect features. I think looking to see if it's in a menu somewhere. It probably is, but I'm not finding it. But anyway, look for this guy that looks like the little no smoking symbol. I see questions in the chat. Is helpers, is that something you guys have, or should I address it?
Well, I think we got it. We had a question about how to get the selected records in blue in the attribute table, and you just run the and then click that little button that says move them to the top.
Yes, exactly. So they'll highlight in blue anyway, but to see them all together, you want to use that button to move them to the top. It's just a handy way to see everybody together. Alex also points out that there's a drop down to show only selected features. Yeah, and that's really handy. I will say I get myself in trouble with that one because when nothing's selected, all the attributes go away. And then I kind of have a panic moment of where did my data go? And for some reason that happens to me every single time I use it. So just know that that's an option that you can make that choice, and then you can make it look like you have no data. The data didn't actually go away. I just wasn't looking at it, but it's one of those ways that my brain works, and you will find yourself with those kind of quirks too, probably working with a GIS if you haven't already. All right, so this is cool, right? We've kind of explored some of our data, and we've seen how we can kind of interact with this data, but we haven't seen how we can actually change it to be representative, like having our symbols represent our data. We've only made our roads gray and our shoreline, whatever the default color is. I have to say I'm not super thrilled about the color choice of that default. So let's start looking at symbolizing some of our attributes. And this may be the last thing we get to today in our quick 2-hour workshop. But like I said, the materials will be online, so you can keep working through this. This workshop was originally intended to be a 4-hour workshop, so we weren't going to get through all of it anyway. So we're going to look at classifying our we're going to symbolize our data based on attributes, and we're going to look at our road data. So I think I'm going to turn off my shoreline here just so I can see everything a little bit more clearly. Feel free to leave yours on if you want, or change the color so it makes you happy. So what we're going to do, the instructions tell us to clear out our selection. So we made sure we did that by clicking on this button. So our street center lines are just plain, nobody's selected. And now we're going to come back to our layer styling panel. Again, I'm going to make sure it's street center lines is selected over here on the left-hand side. And we are going to now pick, instead of single symbol up here in our drop down, we are going to pick categorized. And our data went away again because we haven't told it how to display it yet. So don't worry, it's still there. We didn't break anything. It just doesn't know what to categorize. So for our categories, I want to tell it what value to use. So in my drop down menu, I'm going to pick class code because that's what we were just looking at. You can get more fancy with that, but we're just going to do class code for now. Our symbol we're going to leave as a regular line. And our colors we can leave as random colors for now, but we'll be changing that. The way to get my data back is to tell it to classify it. I will say if you have a ton of values here, or if you have a continuous variable, you don't want to use this. I think it will actually not let you, maybe it will, but you'll end up just having too many categories if it's continuous. You want to use a different tool for that. or a different method. But for here, because we have categories, everything is categorized by, in this case, our categories are numbers, but they're not really numerical kind of numbers. They're just categories. So now we kind of have, mine kind of looks like birthday cake sprinkles, which is okay. Yours will be different colors because it's going to pick default colors. So don't worry if it doesn't look the same. But if I was making a professional map, this is not what I want. I want to kind of play with this and make this look a little bit better. But you can kind of see how all the different class codes work, right? Like I'm guessing this kind of bluish green color here in the middle with the street grid is more like either residential or smaller streets. We've got our freeways and highways are kind of a different color. Our bigger roads are, in my case, yellow. I'm guessing the red is kind of service areas or uncategorized ones. So, okay, now we've actually symbolized our data with using our data, which is pretty cool. What I want to do though, instead of having it categorized by color, is I kind of want to work with the width instead. I want to make all my roads the same color, but I'm going to change the width of them. So what I want to do is I'm going to go ahead and click on my first symbol here and hold down Shift and select all of them. I'm going to uncheck the last one because we don't need it. And then I'm going to right click and tell it I want to change the color. I'm going to, in this case, for my hex code, instead of what it has here, I'm going to use one I already picked, which is alternating A's and zeros. So I'm going to have hashtag A0, A0, A0. So you can think of that as repeat that 3 times and then hit enter to see our color. So I picked a gray because for me, streets are kind of gray. It could be other colors, but now everything's the same symbol. What I can do though is I can change the way that this is symbolized, both in our legend and in terms of the thickness of the line so that it makes more sense. In my legend, I can actually click and tell it, if I double click in this legend value, instead of 0, I'm going to say that value of 0 is called private streets. You can just type right in that box. And again, for 1, I'm going to say those are freeways. 2 is going to be highways. 3 is major streets. So again, I'm just typing, I'm double clicking on my legend item here and I'm typing in the words. 4 is secondary streets. And don't worry, you don't have to do all of this. It can get tedious trying to do this in a workshop. So I'll show it quick and you can do a couple and then decide to leave it for now. So 5 is going to be local streets. And 6 is going to be freeway on-ramps. Freeway ramps. Okay, so I've changed just the name and the legend. You can see over here on the left-hand side of the screen in my layers panel, it's changed the name and actually made them real words instead of just numbers. So that can be really helpful when we make our legend later. What I now want to do is change the way that these are styled. So I'm going to give them different line weights, and the default line weight here is 0.26. So if you're looking at the workshop materials and you see in the table for how big to make the lines, if it says 0.26, you can just leave it. So 0 for private streets is the default. So we'll leave that. Freeways, I'm going to double click on my symbol for freeways and open that up. We saw the similar thing before. So I'm going to click on simple line and I'm going to, instead of making the stroke width the default, I'm going to highlight it and just type 2.0. So now it's going to be bigger. And you can see it already changed in my map preview here. It's made them kind of fat. They look like big fat noodles now. Same thing with my highways. I'm going to double click on that symbol. And again, I want to click on simple line and change my width to 2 because in my mind, freeways and highways are pretty much the same thing. So I'm going to style them the same. For 3 for major streets, I'm going to double click on that symbol and I'm going to tell it I want them to be 1 instead of 2. So they're going to be kind of plump, but they're not going to be as big. For secondary streets, so category 4 and 5, so that's local streets too, I'm going to leave that as the default, so they're going to be skinny. And then for 6 for freeway ramps, I'm going to double click on that guy and I'm going to make it looks like 0.5. So it's about halfway as big. Okay, so now that was pretty quick. but you can do, again, you can do a few of these, get the feel for it. You don't have to do them all. So you can see now we've categorized our streets based on using size based on the category, which for me is a little bit more effective than the colors that we had before. I could play with this depending on the scale. I might want to tone down the thickness of some of the freeways, but for workshop purposes, this looks pretty good to me. So I'm going to come over here. I'm going to remember to save, click the save button because that was a lot of work. And I don't want to lose that. All right, so we have about 10 minutes left in our workshop. The next thing I was going to go through is rule-based symbology. That's another way to look at that. I'm thinking, I'm going to pause for a second and see, are there any questions like, yeah, any questions before we move on to anything else? And I'm thinking that probably we don't have time to do role-based symbology to give it justice. So what I want to do is I'm going to show you a quick preview of what is left in the workshop. These materials are going to stay online, as far as I'm concerned, forever. We just keep updating them. So this is the section we just finished where we were looking at categorizing our streets based on attributes. And so we came up with something that looks similar to this. The next part of the workshop materials goes through rule-based symbology, where you create a rule based on your attribute information. It's kind of similar to what we did before, but in this case, we're going to be filtering out the trees to pick out just the canary pines, for example. So if I want a specific species of tree, and then we go on to make a map and walk through the print composer. So given that we only have about probably 5 minutes left before folks need to shuffle off to their next things. What I want to do is instead just kind of show you in general what you can do with this. You can also select by location. So you can select trees, for example, in the workshop materials that walks through finding the trees that are inside the earthquake hazard zones. So that's an example of spatial analysis that you can do. So that's the rest of the workshop materials, but I think for in terms of instruction for today, we'll leave it there. What I'd like to do though is spend, 5 more minutes talking with you guys and see what questions you might have, or if there's something you want to know about QGIS in particular. Can it do this or that? We can do that as well. So also, I think what I will do is we'll wrap this up and then I'll hang on the call so that you guys can ask questions without being recorded. So I just want to thank you all for coming today. I'm going to stop my screen share. So thank you all for coming today. I know it's a long time to sit through a 2-hour workshop, so I really appreciate you being here, and I hope you learned something that you value, and continue working through the materials. It's probably another hour's worth of materials to work through. So feel free to use those. And yeah, so I hope if you're here for the UC GIS week, I hope you have a good week. And if you're here just for map time, it's good to see you guys. And again, I'll end the call here and I'll end the recording here, and then we'll hang on and just chat.